Welcome to the VLab platform. My name is Umar Adamu. I am an engineer and a technologist in the Department of Electrical and Computer Engineering, based University, Abuja. Today we are going to conduct a simple experiment on how to connect resistors in series and parallel. Listeners are expected to pay total attention throughout this experiment in order to avoid making mistakes during practice. Resistors are electronics components or devices that opposes the flow of current in a circuit. The resistors can be connected in series and parallel, or both series and parallel. Also, the aim of this experiment is to study the characteristics of current, voltage, and resistance in resistors when connected in series or parallel. And also, the basic connection of resistors in either series or parallel can be done in electronics circuits or in electronics connections by connecting them in series or in parallel. For the series connection, the resistors are connected, or the resistors or components are connected end to end, forming a single path for current flow. While for the parallel connection, the resistors are connected across each other, forming a common set of electrical points. I have my DC power supply, which is this. Secondly, I have my digital multimeter, which you can see it here. Thirdly, I have my bank of resistors. It contains resistors of various readings or of various codings. Also, I need to have my breadboard, which is this. And lastly, I need my jumper wires, which are these. For me to start the experiment, this is my breadboard. Then I open my resistors bank to select the required resistors for the experiment. My first resistor is 200 ohms, which is this. I am not connecting it on the breadboard. That is, I'm starting with series connection of resistors. I'm also connecting it to the Vero board. My third resistor is 330 ohms, which is this. I'm also connecting it to the breadboard, as you can see me doing. I am done with my resistors selection, because in this experiment I'm going to use 3 resistors. So this is my jumper wire. I'm connecting it to one end of the resistor. This is another jumper wire, which I'm connecting to the other end of the resistor. So I am going to put on my DC power supply. After putting on the DC power supply, I am asked to use 5 volts in the experiment. So I have to adjust my voltage to the 5 volt. So this is my 5 volt approximately. I am now going to connect the DC power supply to the resistors. And you should also know that resistors doesn't obey polarity. I can decide to connect it from any of the 2 ends of the resistors connection. So I decide to connect this to one end of my resistor, and this is my negative terminal to the other end of the resistors. So now my resistors are connected to the 5 volt DC supply. I now pick my digital multimeter, which is this. This is the digital multimeter. I have to put it on and then take it to the current range for my current measurement. This is my current range. I am now putting it at 200 milliamp point on the digital multimeter. So after selecting my range for measurement of resistance, the multimeter has 2 leads, 2 measuring leads or probes, which are marked red and black. So for my current measurement, let me start measuring the current in my first resistor, which is 200 ohms. And you should know, in measuring current, the measuring instrument have to be connected in series with the components to be measured, as I'm going to do now. To measure current, I have to connect it in series. Therefore, I have to break the circuit. Have to be connected in series with the components to be measured. So I'm now putting my multimeter in series, 7 milliampere. So which is indicated on the multimeter, and I'm entering this reading on the board. After taking my current measurement of the first resistor, which is 200 ohms, it gives me 0.7 milliamp, which I'm entering on the smart board here. Then for the second resistor, I have to bring back the other end of the second resistor and dismantle the other end of the third resistor from the connection, and then insert also my measuring instrument. It is giving me the same current. Also, to measure the current in the last resistor, which is the third resistor, I disconnect one end of my DC supply and insert the instrument in series with the resistors, which is also the same 0.7 milliamp. After done with my connections of the resistors on the breadboard, I will now put on my DC power supply and then set it to the required voltage supply, which is 5 volts, as you can see displayed on the DC power supply. I will now take my positive of the DC power supply to any end of the resistors connected in series by doing this. Then the negative lead from the DC power supply to the other end of the resistors. After doing that, I will then take my digital multimeter. After putting it on, select the proper range for current measurement, which I have already placed it on 200 milliamp, as you can see. So also in measuring current, the digital multimeter is to be connected in series with the component to be measured. So I'm dismantling my resistor now, which is my R1 from the circuit, and then insert the digital multimeter in series. This is the measurement for my resistor 200 ohms, which is 6.7 or 6.6 milliamps, which I will now record on the table. That is for my R1. Connect back my R2 and then dismantle the other end of my R2 to measure the current flowing through my R2, which is 220 ohms. So this is my current, which is what, 6.6 or 6.7 approximately milliamps on the board. The third resistor, which is 330 ohm, I dismantle one end of the third resistor and insert my digital multimeter in series with the components, which is the same 6.7 milliamp. R3. We connect the circuit as it was earlier connected to measure my current, my voltage now. For measuring my voltage, I am to measure the voltage across each of the resistors. So this is I have returned the resistors, reconnected back. So to measure the voltage, I should also select measurement, which is this. So I'm to measure the voltage across each of the 3 resistors. This is my R1. So look, this is the voltage for my for R1, 1.34 volt. 4 volt. Since it is voltage, it just have to be across the component. So this is for my R2. For my R2, the voltage is 1.49 volt. For my R3, this is the voltage, 2.24 volt. My measurement for voltage across the resistors connected in series. Then for the measurement of the resistance of each of these 3 resistors, I have to also select the proper range for resistance measurement on the digital multimeter. So this is the selection for my resistance measurement. For R1, the resistance is 204 ohms. For R2, 227 ohms. Then for R3 is 335 ohms. I am now moving to the parallel connection of resistors to also do the same. I am now going to connect the resistors in parallel by looking at the given diagram on the smart board. I can be able to build my resistors, that is, connect my resistors based on the diagram shown on the smart board, which is the first resistor is what, 200 ohms, and my second resistor is 220 ohms, and then the third resistor is 330 ohms. So I'm now connecting them in parallel as shown in the diagram on the smart board. So this is what my parallel connection for this same number of resistors. And this is my DC power supply, which is still at 5 volts. I'm now connecting it across these 3 resistors that are connected in parallel. This is my negative, cut from the DC supply source. And also it should be known that for parallel connection, the resistors are connected across each other, forming a common set of one electrical point. Just as you can know, 2 electrical points, that is what the negative and the positive terminal as seen on the breadboard. So for my voltage measurement, let me go to the parallel connection table. So this is the resistors value, which is the same as 200, 220 and 330. And this is my current. To measure my current across these resistors that are connected in parallel, I will take my digital multimeter and select the proper range for current measurement, which is this. So this is the proper range for my current measurement in what? Milliamps. So this is what? The first resistor. Let me measure the current across or through the first resistor, which is 200 ohms. I place my multimeter in between. You should know that in measuring current, the instrument have to be in series with the component to be measured. So this is my current through the first resistor, which is was 200 ohms. The current is 24.9 milliamperes. I will bring back the resistor into the circuit or into the network and pull out the second resistor to measure the current flowing through it. So this is my to measure the current through the second resistor. So this is the current flowing through the second resistor, which is 22.6 milliamp. For the third resistor, I have to bring back the second resistor, which I earlier pulled out one of its leg from the network, and then pull out the third leg of the resistor for current measurement. So this is the current through the third resistor, which is 14.9 milliamperes. So these are the currents flowing through each of these three resistors. And from the readings obtained for the current measurement, you can see that the first resistor have higher current, followed by the second resistor and then the third resistor, which shows that the higher resistance, the less current flow through it. So now let me bring back the third leg of my resistor into the network for my voltage measurement. I bring back the resistors. They are now in parallel connection. All resistors are connected across each other, as earlier said, and the voltage supply remains the same 5 volt. And you should understand that for the measurement of voltage, let me select also the proper range for my voltage measurement, DC voltage, which I have placed the multimeter on the voltage measuring range. For your voltage measurement, the multimeter is to be placed across the two terminals or the two legs of the resistor, which is what I'm going to do now. Since they are connected in parallel, so this is the voltage, which is what? 5.0 volt. For the second resistor, it is God given the same thing. Since the resistors are connected across each other, since the resistors are connected in parallel and the supply is placed across each of the two terminals of the resistor, therefore the voltage across this resistor is the same as what the supply voltage, which you can see. 5.04 volt across the three resistors. It is 204 ohms for the 200 ohm resistor and 4 ohms. 220 ohm resistor, the measured resistance is 224 ohms. 224 ohms. For the measured resistance is 334 ohms. So these are the readings obtained for the parallel connection. This is for the current, voltage and resistance. It can be observed that the voltage is the same across the resistors since what they are connected in parallel, as we earlier said. After carrying out this experiment, we can also use what a formula which is giving us 1 all over R equivalent is equals to what? 1 all over R1 plus 1 all over R2 plus 1 all over R3, then plus 1 all over Rn. So this formula also can be used to calculate the resistance when connected in parallel. So after these two experiments, after I carried out this experiment on these two methods of connecting resistors, that is in series and in parallel, it can be observed that the reading for current in series connection shows that the current is the same across all the resistors, while the voltage depends on individual resistor, and the measured resistance is not the same as what the coded value of the resistors. And also for the parallel connection, it can also be seen that the current is not the same for these three different resistors, while the voltage is the same across each of these three resistors because of what the parallel connection. Also for the measured resistance, it appeared the same to be for both, to be the same for series and what parallel connection. So it can be noticed that for a parallel connection, the network is what? More reliable compared to the series connection, whereas it is just a single loop that is used for the connection of those components. While for the parallel connection, each of those components have direct access to the supply source. So by uprooting one component in a parallel connection doesn't affect other components in the network. While for series connection, when one component is pulled out of the network, other aspect of the network is also disconnected from the supply or from the system. So therefore, a parallel connection is more reliable and more efficient than series connected system or network. So this is the end of this experiment. Thank you for your audience.